Okay, topic 7.0, which is redox reactions. Okay, redox is a combination of two words. It says reduction and oxidation. So, reduction and oxidation. These two processes always happen simultaneously. They always go together. It involves the transfer of electrons. Okay. What type of compounds will this reaction consist of? That's what we are going to see. Okay. In a redox reaction, the number of electrons gained or lost will be equal. Okay, gained must be equal to the number of electron lost. So definition, okay, oxidation is the removal of electron, or it is loss of electrons. Reduction is what? Gaining or addition of electron. Okay, if a metal lost its electron, or if any element losing its electron, it is losing its negative charge, so they will become more positive. And if they are gaining electron, they will become negative. Okay, so you can use an abbreviation like oil rig for remembering the definition. Oxidation is losing and reduction is gaining. So that will help you to answer few questions later. Okay, let's go ahead and decide, and or we can see how the oxidation and reduction happens. How can we decide that? So the terminology, you already seen this, it is called oxidation numbers. Oxidation number is a scientific word, scientific terminology for charge of an atom. We know that when they are reacting, they will either lose or gain electron, and it will be indicated by the charges. If they are not reacting, that means they are single, that means they won't lose or gain. Their charge will be what? Oxidation number will be 0 for single atom, means uncombined. Okay. Oxidation number of a combined element will be equal to the charge of that ion. Then sum of oxidation numbers for a compound will be equal to what? Say for example, one atom is losing electron and other atom is gaining. So Na plus Cl minus 1, the total will be always equal to what? Because compound doesn't have a charge, it will be always equal to 0. If it is a polyatomic ion, their sum will not be 0 because it is an ion. It will be equal to the charge. Say for example, if it is phosphate, it has a charge of 3 minus, okay? That will be the charge of phosphate ion. Then if you have a compound with two different elements, always the atom on the right hand side, which is the electronegative atom, okay, that will be always what? Negative. You already know that the first element will be positive and second element will be negative, because the second element has a higher electronegativity, it will gain, and the first element has lower electronegativity or lower ionization energy, it will lose. Then some of the charges you are going to memorize. For pre-AP, we are saying oxygen is showing always what? -2. That is not actually true, but you don't need to worry about the other charges of oxygen. There are some exceptions. Also, hydrogen is also like that. Hydrogen has 2 charges, but you are assuming everything is what? +1. Then some of the cases, group 1 metal, they will always show only +1, and group 2 metals like magnesium, they will show +2. And we are using this to find the charges of other one, oxidation number of the other one. Okay, let's see. On your test, I will ask, okay, go ahead and find the oxidation number for the highlighted elements. Okay, so we are doing an algebraic equation there. So we know the charge of potassium because it is group 1, charge of potassium is 1, and you don't know chromium, so I'm going to write X there, or variable, any variable. And oxygen also we know that it is -2. And we know that all these charges, when we add them, it will be equal to 0. That's a compound. We said for a compound, charge will be equal to 0. Okay, so I'm going to make an algebraic equation. So +1 charge of potassium, and there are how many potassium you are saying here? 2, so I'm going to multiply with the 2, plus there are 2 chromium, so it will be 2x plus -2, how many there? 7, so -2 times 7, and all of them will be equal to what? 0. It's an algebraic expression, just go ahead and solve this. 1 times 2 is 2, and it is 2x plus, I'll say -14 equal to 0. So 2x is -12 equal to 0. 2x is equal to +12, and x will be 12 divided by 2 will be +6. And since it is an oxidation number, you have to show always the charges, even though it is positive. Whenever you write 6, that means it is +6, but you have to write the positive there, and you have to tell that whenever you say it is +6. Okay, that's how we are finding the oxidation number, and these are the practices we are going to do. Okay, so I'm going to highlight this. You are going to find, I'm do all the alternate question maybe. Okay, so Fe, okay, this is how we are going to do it. X, this is -2, and it is equal to 0. There is only one atom, so expression is very easy. X will be what? +2. And if you are doing the other one, this is x, this is -2, there are 2x, -2 times 3, -6 equal to 0. So x will be what? +3. And chlorine, since it is connected to chlorine itself, none of them are losing or gaining. So it is like an uncombined element. I would say it is the same element. So the oxidation number will be 0. So oxygen, here it is -2. So there is x. So x minus 4 is equal to 0. So that will be +4. And go ahead and find this for manganese. Oh my God, that's a not highlight. So manganese, carbon, nitrogen, chlorine, and sulfur. Okay. And for manganese, you will get 8 plus 7. Carbon, you will get -4. This one, just put +1 and -3 because you can't have two variables. So x will be +2. This is the one different, okay, because it is polyatomic ion. So that is not equal to 0. That will be equal to the charges. So I'm going to write the expression x plus 1 times 4 equal to +1 because it is not a compound. So x will be what? -3. Same thing for all of this. Okay. So chlorine will be +5, and this will be +3, and this will be +6. Okay, once you're done, we are going to see how to apply that in an equation and see how can we balance equations. Okay, for that, I'm going to draw a number line that will help you with some of the people's, those who struggle answering the questions. Okay, so everyone go draw a number line here. Just put 0 in the middle and 1, you know, the number line. Okay, 3 here, like just continue like that, and this will be -1, -2, -3, and write red here and ox here. So it is going right way, that will be oxidation. If we are going this way, that will be reduction. Okay, let's answer this question. There is a typo here, it is Fe. Okay, so on a reaction, Fe was 3 at the beginning in reactant side, and it is converted into 0. That means the number changed from 3 to what? Number changed from 3 to 0. Okay, look here. This is 3. Okay, I have to put a highlight. This is 3 and it is going this way. So it is going towards the reduction, or you can say the number is decreasing. It gained electrons, thus that will be what? A reduction. Same thing, it is +2 to +6. Number is going towards the right. So that will be what? Oxidation. Because if anyone need help, I'll draw that too. Let me get a highlighter here. Different color. Come on. Okay, so here Cr2 was here. It is going towards this direction. Okay. So now you can answer. It is -2 to +2. It is increasing oxidation. If it is increasing oxidation. Okay, just add a note there if you are needed a explanation. If oxidation number increases, that is oxidation. If oxidation number decreases, that is what? Reduction. Okay, now we are going to learn how to balance redox reaction using half cell reaction method. Okay, let's do that. Is this? Okay, so I am already one question is solved for you. I'm gonna teach this. Once you are done with this, go back and go through that one, then you will understand. I don't want to go over the question already did. That is just a waste of time. Okay, so we are going to balance an equation using a method called half cell or reduction oxidation method. Okay, so first what we are going to do, you have to find the oxidation number of each and every element here. So this is the equation. Okay, zinc is by itself, it doesn't lost or any electron, so it is 0. And chlorine, we know that chlorine is -1. There are 3 chlorine, you can just write -3 equal to 0. So iron will be what? +3. There is an arrow here. And chlorine again -1, there are 2 chlorine, so this will be what? +2. And here chlorine -1, there are 2 chlorine, this will be +2. So that is the first step you are doing. Okay, so assign oxidation number for each element, then we are going to identify which one undergo oxidation and which one undergo reduction. Okay, I'm gonna draw a line, use a different color. So zinc was 0, it goes from 0 to what? 2. That means it increases the number, so that is called what? Oxidation. Now let's go choose a different color, maybe green. Yeah, Fe was 3 at the beginning, it's go from 3 to what? 2. It decreases the number, which is called reduction. Now we are going to separate them into 2 half reactions. So like the pink arrow, I'm taking all of them down. You don't need to take the chlorine. I'm just taking the ions, okay, like this. Zinc produces what? Zinc 2 plus. We know that it is 0 become 2 by losing how many electron? 2 electron. So that is called oxidation half cell reaction. Oxidation half reaction. Now look at the Fe. I'm not writing chlorine. We don't need that right now. Just take the ion. Fe3 plus become what? Fe2 plus. Gaining how many? Just 1 electron. Okay. Oh, I had to write that on the other side. Okay, let's see. I'm writing that here and need more spaces there. So Fe3 plus gaining 1 electron forming Fe2 plus. Okay. Now we know that zinc is losing 2 electron, but iron is gaining only 1. Okay, and this is a reduction half reaction. But we need to make the electrons equal, because if iron is receiving 1, zinc is losing 2, that is not balanced. So what I'm going to do to make them same, I'm going to multiply the whole equation with what? 2. So the first one remains same because we are not changing that. Second one I multiplied with 2 everything. So it is 2 Fe3 plus 2 electron giving 2 Fe. Now the electrons are balanced. Now what we are going to do, we are adding both of them. So like a math equation you are adding if you are confused, or just watch me. So I'm adding left hand side, there is zinc on the first one plus 2 Fe3 plus 2 electron. Then draw an arrow. Right hand side it is zinc 2 plus 2 electron plus 2 Fe. We added both. Now I'm gonna cross out, cancel the electrons on both sides, like 2 electron and 2 electron, because it is consumed, the electrons are not anymore, or we are just cancelling like a math equation. So now you have a balanced ionic equation there. So I forgot to write 2 there, sorry. It's 2 plus here, 2 plus here. Okay, so what we are going to do, we are going to replace the ions. We are going to replace the ions with original compounds. See, we separate them from the chloride, okay? Just go ahead and do it. So I'm going to write zinc plus 2 Fe, and it is not Fe plus. We know that it is FeCl3, producing zinc chloride plus what? Plus something happened. This is not writing. Producing Fe, I think it's FeCl2, and there is a 2 here. So that is a balanced equation, and this method is called redox reaction half cell balancing method. Okay, now just go ahead and watch this, go over this. There is one question already done for you, and then do this practice and come for tutorial if you still need help.